Hello, men and women of science. This is Mr. Cochrane here with an introduction to stoichiometry. In stoichiometry, we're going to learn how to calculate values involved in chemical reactions. And to start with, we're going to look at using mole values involved in chemical reactions from chemical equations. So here we go. All stoichiometry calculations, as I said, use a balanced chemical equation, and in one form or another, they use mole ratios from that balanced chemical equation to calculate amounts involved in reactions. All stoichiometry does start with the balanced chemical equation, and here's one right here where aluminum reacts with copper 2 chloride to form aluminum chloride and copper metal. We have seen this single replacement reaction in class. If you look at this chemical reaction, there are 2 chlorine in copper 2 chloride and 3 chlorine in aluminum chloride, and so to balance it, we would put a coefficient of 3 in front of copper 2 chloride and a coefficient of 2 in front of aluminum chloride. That balances the chlorine where we have 6 chlorine on each side, and to finish our balancing we would put a 3 in front of copper and a 2 in front of aluminum. These coefficients give us the relative amounts of each substance in the reaction in moles. So what is a mole ratio? Well, it's the coefficients that tell us the number of particles involved in this reaction, and we could say the number of particles in moles. So 2 moles of aluminum would react with 3 moles of copper 2 chloride to produce 2 moles of aluminum chloride and 3 moles of copper. So we could put these values in any mole-to-mole ratio that we wish. So again, the mole-to-mole ratio of copper chloride to aluminum would be 3 to 2, and we get those values from the coefficients we use to balance the equation. Another possible mole ratio, looking at moles of aluminum to copper chloride, again we would just use the coefficient values involved with balancing the reaction. And other mole ratios from this equation could be 2 moles of aluminum chloride to 2 moles of aluminum, and we could have 2 moles of aluminum to 2 moles of aluminum chloride. So the type of problem we're solving for would determine which mole ratio we would use. So let's try a mole-to-mole conversion problem. This question asks how many moles of aluminum are needed to react with 4.8 moles of copper 2 chloride. Here's our balanced chemical equation that we need to start with. When problem solving, you want to identify what you're starting with, in this case 4.8 moles copper 2 chloride, and where you're headed. In this case, we want to find moles of aluminum. To start with, you'll want to write down the starting value with the unit and the substance. Those are both important. Our units here are moles and the substance is copper 2 chloride. Students who have difficulty with stoichiometry calculations often forget to include their labels. So we want to choose a mole-to-mole ratio that converts from the units that we have, moles of copper chloride, to the units that we want, in this case moles of aluminum. And you can see from our equation, for every 2 moles of aluminum chloride, there are 3 moles of copper 2 chloride. The units, moles copper 2 chloride, factor out, and now we can grab our calculator since the moles of aluminum are what we are looking for. We would multiply by any numbers on top and divide by any numbers on bottom. So 4.8 times 2 divided by 3. Now we hit our equals button and round to 2 significant figures and circle our answer. To solve a mole-to-mole stoichiometry problem, then, you're going to start with a balanced chemical equation. You're going to write down the initial mole value with the unit and the substance. You're going to choose the mole ratio from the equation that factors out your initial mole value and gives you the value of moles that you're looking for. And then you're going to enter the numbers in your calculator and round to the appropriate significant figures. And usually that's based on the initial quantity. Our mole values or coefficients don't limit us to just one significant figure here. Those are called pure numbers. And then you should circle your answer. So pause the video here in a second and then write down these problems in your notebook. Copy the balanced equation first and see if you can solve for the correct mole values. When you're done, go ahead and start the video again and see if you've calculated the values correctly to the correct number of significant figures. Okay, go ahead and pause the video now. So here's the answer to those questions that you just practiced with. Hopefully you got the answers right. If not, go back and watch the video again to see how you convert from moles of one thing to moles of another. Or you can bring your work in and share it with your teacher and see if they can't give you some help. I hope you found this mole video helpful. This is Mr. Cochrane signing off.